Hello and welcome to my VV Gamma graphics tutorial. So in today's tutorial we're gonna create something like this. So finally a PLY point cloud visualization all inside vvvv. And we're using PLY for today. So this is how it works. So it's a PLY point cloud scan thing. I couldn't upload this PLY data to Sketchfab because my account was a free account. So you might need to find a PLY point cloud data somewhere or something that you already created. But I know this is a topic that is interesting for a lot of people. So I wanted to cover it and finally figure out how things work. So yeah, let's get started. So this is the ideal patch that how it looks like. So we're basically gonna start building up all this by scratch. So just delete this one and create a new one. So we're gonna start everything from scratch. First of all, we need Stride. Oh, by the way, to follow to this tutorial, you will also need this vl.io.ply. So if you go to Nuget, just look for vl.io.ply. And you should be able to see this one. I think it was made by Urig. So just copy this and then you go to the Nuget and then install it from there. So manage nuggets and command line and just type Nuget install package. So we didn't need this package. I already have a tutorial explaining how to install these nuggets, but this is how you do it. Nuget space install space the name of the pack and the version, and then if you press enter you should be able to open it up. And also there is a help patch. If you already have Fuse installed, there is a PLY render a PLY point cloud help patch that already is included in the Fuse. However, it doesn't work on my system, and probably that's just because I have an older version of Fuse. Maybe I haven't checked the recent one, but 1.0.2 didn't work for this one. If I press read or whatever, it just doesn't read. I don't know why. So we're recreating things using that vl.io.ply plugin. So yeah, let's get started. So we have this, we have Stride opened up. Oh, I also need my cursor. So application, no, extensions, and I just have this key mouse. We have Stride, so we'll need a scene window just to make sure that we have something on the left top. And then we'll need a root scene, and I'll add a skybox light just in case that it's scary if it's black. So yeah, we have the sky now, we have all the controls. Next up, we'll be rendering a particle. So we need a buffer to render entity again. Oh, we need Fuse activated first. And then we'll get the buffer to render entity. And this one be connected here. And we're gonna be using sprite as the last time. So just get this sprite effect thing out. And then we'll need position, particle, color, particle. So we're gonna get the color from the PLY as well. And then the size. And we're not gonna connect this yet, but will be connected very soon. And also for the size, I want to multiply this because it always gets, when the particles, each dot gets too big, then it gets heavy. So I'll just get this and multiply it by 0.02 or 0.1 or something, just in case I don't render something too big. So next of all, we've already learned how to build up the particle system. So we also need the structured buffered resource, and we need a name, point cloud, whatever, and then we will also need an element count. I'll just set it to 10,000 or something for now. Okay, so next is compute system and compute stage. So we're not going to add any effects like turbulence and things like that for today as well. We're basically going to be using this compute stage, so it's static, and we need to right click resource, and then we connect this resource here and the compute stage here. So now the basic setup is done. We'll use also the common attribute. I think we did this for the last time as well. And here it has all this parameter that we need. So we're going to be connecting the PLY position to this common attribute. So next thing, let's read our PLY. So if I go to the PLY, oh, it's already open? No. there should be, oh yeah, vl.io.ply. So we're going to be opening up this one. And then if you go into PLY category, there should be, yeah, PLY readers open. So we have a few different ones. We're going to be using the one with the color and the XYZ. And as you can see, they have different names. Like this one is a buffer, and this one is an RGB, so it comes out as a spread. But today we don't need that. I mean, we can use this one. They're both almost the same, but instead of that, let's just use this buffered one. So PLY reader XYZ RGB buffer. And here we're gonna specify the path for the part PLY that we want to read. So I'll get my point cloud folder, which should be on my machine. So wait a second, it should be here, and then it should be okay. Yeah. Okay, so I've got my directory, so I'm gonna copy paste that one here. Yeah, so I have this 08146000. I see. Oh no, this one's too heavy. The other one, sorry. This one's lighter. Yeah, so we've got these. So what we're going to be doing, yeah, let's just read it because I think it takes time on complete. So first thing we want to do is, so last time we used this dynamic buffer to convert a spread into a buffer, but this is already a buffer, vector4 buffer, so we don't need this. Instead of that, we need the get buffer, was it? I always forget this, no. Oh, get item, yeah, so we need to get item. And this doesn't get connected here, so I need to convert dynamic buffer to buffer. Yeah, so it should be buffer in, yes, if I remember correctly. Yeah, so it's a buffer in, and then we need get item. So this converts it to the shader node. So now we should be able to connect this one to the position. However, there is a problem. So right now this buffer says vector4, but this position says vector3. And this gets rendered wrong. So what we need to do is we need to specify this as not as a vector. So if you connect it directly, it will automatically be detected as vector3. But then it gets weird. So what we're going to add is we're going to add a node called XYZ, and then disconnect this here because we no more because it already got selected as a vector3. Can't connect this one anymore. If we unconnected, it gets darked out, and then if you connect it here, now this output gets converted to vector4 and then output as a vector3. Another thing we can do is if you get a pad like this and say XYZ or whatever name, if we right click and configure, we can also set a specific data type on our own manually. So let's say shader node vector4. So in this way we can also have the same result. So now this output is a vector4 shader node, and then we can connect this one here. I mean, both way works, but if you don't have a specific node that converts this for you, you sometimes need to make this pad by your own with specific how to say data types. So just keep in mind that this is also useful. So once this is connected, I think it's all good, and it seems like all the particles from here is red, so I should be able to render, but I'm not seeing anything, and that's because this guy's blue. And to fix this, we just have to let's connect the position here, and just in case, let's also set the size. Yeah, oh, size is already in default 0.01, so this shouldn't do anything wrong. So then let's press F9. So once you click it, you should be able to see the point cloud somewhere. Okay, now it's loading, so it's not there yet. Oh, by the way, this one has quite a lot of particle mounts, so it gets heavy. So later on, I'm also going to explain how to make it light. So for some of you, it might be better if you build the final part before, because machine might just crash whenever you read this PLY. So yeah. Okay, let's try scaling this guy up to see if we see anything. We don't see anything, and what's the reason? So we have the position. Maybe set the lifetime to 0. Nope. The particle's red. We have point cloud. We have sprite. Everything seems to be fine, but I'm not seeing anything. We don't need a skybox light, but we can keep it there. Oh, let's set the color to 1. Okay, we're not seeing anything yet. That's strange. RGBA buffer, reverse phase winding. Let's try that out. This doesn't help, so we're not seeing anything. Okay, let's just connect the colors first to see. I'm not sure what's wrong. So buffer in, and then we'll set these as a color. So this color already comes with RGBA, and this one is a vector 4 input, so it should all be fine. And then now we can connect this color here as well. Okay, so we're seeing one dot here, so it's been rendered, but we're not seeing it. And what could be the reason? Color, sprite, size, it's all good. Yeah, don't make this too big, because let's set this to 0. Size really small. Oh yes, we don't have the get item, so this guy doesn't know the index, but so we need a threaded dispatch threaded ID, and then we'll just connect these ones here. Oh yeah, here we go. So we've got all our particles drawn, so we don't need the skybox light anymore. And as you can see, this should be a forest, but it's not, and that's because the element count is not enough. So I just point this up to like 50,000, which is already pretty much, but we're not seeing everything yet. So the maximum amount that we have here, if we type, so this says the amount, like if you hover this up, this is the amount of particle we have. 1, 10, 100,000, 10,000, 100,000. I don't know. So it's a lot. So I think I need another 0 here, but I don't want to go that high yet because it's going to make it too heavy. But I want to have the element count. So element, if you type element, there should be a, yeah, let's get this include low level node. And there should be a get element count or something. Yeah, get element count and compute. Yep. Oh no, it's not element count. It's just element count. Yeah. So there should be a node called element count. So let's just connect this one here, and now we've got an output as a integer 32, and this is the element count in total for this PLY, which is too big. Okay. And another thing I want to do is, so my PLY, this is my PLY specific problem, but it's rotated a little bit. So I'll use a node called rotate X. Rotate X, yep. And then I'll connect this one right here. And then right here. I think it's the X axis, yeah. So I'll do it minus 0.25. And now you see the tree standing. So this should be correct. Okay, so this is like the basic setup on reading point clouds, but I want to connect this and I want to render the entire forest, not just this part, but it's way too big. So what I want to do is I want to make a sphere. So I'm going to use called the distance, and then I'm going to say, okay, so I'm going to set this vector 3, and then I'm going to add a node called position. So this gives all these positions. So we're using the same node as this one, but we're going to calculate the distance between these particles and 0, 0, 0. So if the distance is from the center, if the distance is, let's get confused on this one. If the distance from the center is like 10, I'm not sure what 10 is, 10, then let's only choose the particles that's inside this 10 area, and the ones outside I don't want to render them. To do so, there is this node called select stage, and this one actually selects the indices of the certain that's out from here, and the one that's on, then it will output the index number of those ones, so that it only renders that specific area. I'm going to connect this one here. It's enabled. And then I'm going to connect this one to the compute stage. But yeah, right now, so I need to add another compute stage. Oh no, I need to connect another one to this compute system, but right now it's connected here. So I'm going to add a node called group. compute stage, and then here I'm gonna disconnect this structured buffer resource, because that means right now it will only render this one, but I want it to render this one and this one. I'm gonna disconnect that, connect to the group, and then connect the group to compute system, and connect the select stage to this group so that it renders this and this. Press F1 again because it got blue. Read. And I'm gonna wait for a while. Let's connect an orbit camera. Oh yeah, so now I got render, I got all these things. So let's see what it does. So right now it's only being rendered a specific area, but if I lower this one down, nothing happens. Oh yeah, and that's because this one is already being rendered. And one interesting technique that I realized, and this might be common for everyone, but these particles, so when I was playing with this emissive particle, and I realized, and I also had a simulation, so all the turbulence were flying around. But while that, if I turn this enable off, it stopped, like it stopped that frame as an so all the simulation stopped, but it didn't stop the simulation, it stopped in the specific point that everything was. So all the particles were like in between with the shape that I wanted to stop, which was great. And it also lights your system up. So right now I think everything is working on, oh wait, F3, yeah, 60 frame right now. But if I turn this on, oh, it doesn't drop. But I think if I go, for example, to like 80,000 or maybe more, oh, it doesn't. Let's try connecting this one then. Yeah, so if I if I render everything, as you can see here, it's really small, but it says the FPS is like 10. But if I turn this enable off, it still has all these particles rendered, but the frame rate goes all the way up to 50, which is quite smooth. So I'm right now rendering the entire PLY scene, in the same time having all the frame rate pretty smooth. But if I zoom in, for example, there's too many pixels, like dots, drawn, and then I can see the frame rate going down. But I want to go here. But there's no way I can. And to do so, I'm using this function here that masks the position, like certain position, so that yeah, I can go all the way there. So now this one is turned off. Oh yeah, and I need to connect the select stage to the buffer to render entity, but right now I have nowhere to connect. And there should be a pin that allows me to connect this indices. Oh yeah, so there's a show indices, I guess. Yes, so now if you right click, continue, there is a pin that you can activate called show indices, and here we should be able to connect the select stage one. Once we do this, as you can see, yeah, it had some sort of bug, so now as you can see, right, so it got masked. So if the distance from the center is more than 10, then it will be, the particles will be deleted because it's not sending the indices here. So now if I change this value, I can change the amount of particles that will be drawn, which is pretty cool. Yeah, so by using this technique to select the indices, you can actually make the PLYs rendered pretty fast, and also a decent amount that you want. And the trick here is that once you disable this one, the thing is you can't change the size here anymore unless you enable it again. So now it got a bit bigger. And that's the cool thing, to have all the parameter controls here as well. So we have size here. So, and this one is after this compute stage, which means that we can control the parameters here. So if I set this one to like a bigger amount and then turn it off. Oh, no, let's make it small. Yeah, let's make it small, like, and then make this as a default. And now I can make it bigger or smaller as I want. Right here, not above compute stage. And we can do quite a lot with this actually. So for example, if you want to get the orbit camera position, and then use this distance node with the position node. We can also say size, and then I'll get another multiply, and then I'll say based on the camera position, let's make it a bit smaller. Distance, size, should be good. Let's make this one a little bit smaller. And then I'll enable once and then disable it again. So now if I get closer, as you can see, the particles in the front are fading out. Make it a little bit bigger, so it's as close as it is to the camera, the particles will disappear. And we can add this kind of function not above compute stage, but after this compute stage, which is pretty cool. So we can also play with the position and the color right here, rather than doing things above. So maybe we will be able to add some noise. Unless we can try that. 3D vector scalar, and then let's multiply this with scalar. I'm not sure if your machine can handle this, but we can try. Okay, let's add -1. No, 1 minus here after this noise, because it's right now it goes all the way to the minus, and then I'll decrease the multiply. Yeah, so we can add some noise on this position as well. Oh, this is pretty cool. So we don't have to do all these on the above compute stage. We can do everything at the bottom. Yeah, this is cool. We can play. Ooh, yeah. Let's change the noise type. Oh, let's change this one to turbulence. Yeah, now we can play a lot with our PLY. Okay, so I think this is the easiest way to read the PLY point cloud as a point cloud. And once you have all these working as a system, like changing PLYs to different location should all work, and you have all tiny controls that you can add. You can change colors, position, scales, whatever. So feel free to play around and let me know how it worked on your side. Yeah, I hope you enjoyed. That was it for today. Thanks for watching. I'll see you next time.